What did you have for dinner last Tuesday? Not last night, but a week ago. Think about it. What did you have for dinner last Tuesday? Maybe you can't remember. If it was Taco Tuesday and you had tacos, maybe you do. But ultimately, it's something that we just kind of forget. It's something that you'd have to work really hard to try to remember. There needs to be some memory associated with it. But if I said, what did you have for dinner at your last birthday or a big anniversary dinner, or a nice, maybe it was Valentine's Day and a date? If I asked you then, you probably can remember. So the question is why? Why can we remember something that may have happened a year ago, but we can't remember what happened last Tuesday? Well, part of that is how our mind interprets information. Think of your mind like a computer, and you have sensors. Our senses are sensors. So we have eyes that are like cameras, ears that are like microphones, and we're constantly receiving data and information. We try to make sense of that, and we store those as memories. So if we think about this picture here, okay, we have, what's going on in this picture? Let me ask that question to you. What is going on in this picture? Somebody's got to answer.
I would assume they're having a birthday party of some sort because of the cake.
Yeah. All right, so we have a cake, right? That is a clue. We have a visual clue. And then we have these fireworks that are kind of like candles. So this must be a very fancy birthday party, right? But they, in the video, they're singing. And so as a human, if you were to just have teleported right into the situation, you'd probably start singing along and you know what to do and how to react. Okay. But a computer, here's how they're going to look at it. When we're talking about artificial intelligence, this is how an artificial intelligence computer or system would interpret what's going on. The first thing it's going to do is use computer vision to understand what it sees. It's going to know that there are people there. It's going to see that there are glasses, that there's a hat. It's going to see that there is a cake, but it's also going to see that there are fireworks. And that's going to confuse it because fireworks are typically associated, in its understanding, is probably around holidays, like maybe the 4th of July. Okay. But all the other things say it's a birthday party. Now, with enough training, the AI system's probably going to determine this is a birthday party, and the robot might even be able to join in and sing if it's been taught to sing. But the point here is, how does it interpret what to do? Well, it sees those fireworks, but it also doesn't see any sky. So it might be able to assume that the fireworks are out of context and even kind of ignore them, right? But it also looks like you've got candles here, and so it also, ultimately, hopefully, the system is determining it's a birthday party. Now, the only way it could do that is if it had seen hundreds of images before where there was a cake and people singing and kind of similar things, where it had been taught all these scenes are birthday parties. And all these scenes are the 4th of July with these fireworks, or this is a firework. And so we use machine learning to understand and to comprehend, or for a computer to understand and comprehend what it is seeing or receiving and what information is. Okay. So I've just used that as a basic kind of like illustrative purpose point of like, how do we know how a machine uses AI to learn and understand? Okay. Any questions so far? All right. So humans learn by associating memories and emotions and kind of all of these things together. And we're going to be talking about how machines will use what we call machine learning or deep learning. And a lot of times it's statistics or data analytics, and natural language processing. All of this is part of AI, and a way for you to understand kind of what do we mean when we talk about artificial intelligence. And we are meaning that artificial intelligence makes up all of these other fields and disciplines. Okay. So I'm going to give you some terms. You can take notes on these if you want. They're always going to be provided in the video and in the slides. So it's up to you if you want to actually write them down, because it helps you to focus and learn it. That's fine. But I'm going to be going over the terms. So when we talk about artificial intelligence or AI, we're talking about a computer system that can perform tasks that normally require human intelligence, such as visual perception, speech recognition, and decision making. And they're really good at kind of detecting patterns, okay, and understanding and finding trends and patterns. And that is something that AI is really good at. AI is a very broad computer science term now that includes a lot of things. And so we'll see this, we'll kind of try to break it down to the different disciplines inside of artificial intelligence. There's this professor who has done this amazing example of explaining all the sub-disciplines inside of artificial intelligence. He does a much better job of presenting it than I do, and I've tried to even memorize it and I can't do it, but he does a good job, and I'm including the video, and I'm just going to include the link on Sakai, and I want you to watch this 5-minute video that kind of breaks down a lot of the terms and things, and you can see how it all interrelates as we go. It's a great example. We're going to use the term machine learning. Machine learning is an application of AI. It provides systems the ability to automatically learn and improve without explicitly being programmed by an individual. So machine learning focuses on the development of the computer program, and it's accessing data and learning and enhancing and learning for itself. A good example are recommendation engines. So things that tell you what to buy based on people like you, or people who've looked at products like you, or previous things in your cart, those kinds of things. Those are built on machine learning algorithms. And they're also used for a lot of business kind of predictive analytics. And so being able to understand and make sense out of large amounts of data. Questions so far? Another term we're going to use is natural language processing, or NLP. And the opposite of that is NLG, natural language generation. So natural language processing is the ability of a computer program to understand human language that's spoken to us. We've seen this in Siri and Echo and Google Assistant, whatever your favorite assistant is. But the ability to respond back is natural language generation. Now, typically we have NLP and NLG, and in the middle was a lot of machine learning to figure out how to respond. Okay, so what you're going to be making with your chatbot assignment is the NLP and the NLG, but we're going to kind of hand create all the stuff in the middle. We're not going to use machine learning, but you could over time learn what people are going to ask and then provide data and information to that. In artificial intelligence, you hear a lot about neural networks. Neural network is the underlying system of how AI works. It's basically the idea that you're programming a computer to work the same way that a human neurons and connections are made, and it works the same way. Let me be really clear. I am not writing neural networks. I don't know how. I'm not anywhere in the realm of intelligent enough to do that. There are a lot of really smart PhD researchers who are doing that, and writing very efficient algorithms for machines to learn and interpret information. We are able to leverage those things because they make them available in APIs, application programming interfaces. They make them available as algorithms that we can use. But most of the people who are there are a small subset of people who are building and designing new neural networks. Most people are leveraging existing neural networks. For example, we use a lot of Intel's neural networks, and we use algorithms that are built on top of that for specifically like mass detection on the projects that we've worked on. Now, all these terms have a lot of people in marketing space using and misusing them. Okay. When we talk about deep learning, this is a subset of machine learning, but it typically has to do with dealing with unsupervised data that is unstructured. Okay, when I say unstructured data, think of that as like written form. So someone has written an email, and there's information and data that can be collected from that, but it's not in a spreadsheet, right? It's not in a database. When we talk about structured data, it's typically a database, or think of a spreadsheet that's organized and easy to extract statistics out of. So a lot of deep learning is about going really deep into that unstructured data and making sense of it. And then also the ability to do it without being supervised by a human. Now, I'm not talking about supervision as in we're watching the machine work, but supervised learning is where a human says, this, and this, that is a birthday party. This, and this is a Christmas party. Okay. Unsupervised learning is where the system can on its own infer and learn that that is a birthday party and that is a Christmas party. Okay. It's going to be able to do that over time. So deep learning, like there are a lot of people who are doing machine learning. There's a much even smaller set doing deep learning, but a lot of people claiming that they are. Okay. Here is a kind of it's actually a pretty limited scale that I gave you to try to explain this, because cars kind of use all of it, but it's limiting in its analogy here. So just stay with me for a second. I just wanted to kind of illustrate some of the terms that we're going to use. So natural language processing, that is, as we've said, the ability to infer and understand. So something like Amazon Echo, and it uses machine learning to deliver that information back. Okay. But something like Netflix is just using the machine learning part to deliver what you should watch next, or you like this, therefore you'll like that. Okay. When people talk about augmented intelligence, that is where the AI system provides insight and information to a decision maker, and then ultimately that human is making a decision. Right now, that's a lot of the work in AI, is just kind of augmenting the decision-making process, like giving information so people can make better decisions. But the machine itself is not actually making the decision. When we talk about AI decision-making, we're talking about, like for example, a self-driving car, where the autonomous vehicle is using machine learning to understand. It's processing natural language, like from signs, an example, and then it actually makes a decision that it should stop. Okay. So an example of augmented intelligence would be the warning system that beeps at you and tells you to stop, versus AI decision making is where it actually knows that you should stop and then it presses the brake for you. Does that make sense? So one's a next stop for the other. Now in a car, that's really smart. That's how much faster than just telling me. The car can make the stop for me and keep me out of an accident. But is this something that we want in our nuclear weapons, for example, where it makes a decision based on data and automatically launches them, right? Like those kinds of questions come in, and lots of different ethical things that we'll get into a deeper discussion later. When we talk about full self-aware or self-learning AI, there are arguments over if we've reached this or not, depending on how you define it. But the idea of a self-taught musician, can a system start in kind of like an adolescent form and learn how to be creative, right? And that's where some people think we're already there. Some people think we'll never get there. I don't think we're ever going to actually get there, but it is something that science fiction movies are written on and people love discussing. And it is a goal that a lot of neural network data scientists and engineers are all working towards. So let's look at some of the applications of this. We've already mentioned chatbots, natural language processing for interacting with people. So there's one that I have created for one of my previous classes, where if you wanted to know if there was if we had class, or we had a test, or what we're going to be studying, those kind of questions are going to be answered. And that's basically what you're going to be doing this week, is creating a chatbot. Slack has its own bot. If you've seen that, it's a helpful tool, gives you information when you need it, but it's learning from all the other people that are using Slack to be as helpful as it can be. So if you want to interact with my chatbot, you can go to Messenger, and it is Cujo AI. So if you look for all lowercase Cujo, as in Stephen King's book Cujo, that was my nickname as a kid, Cujo AI. So we've built a few projects that use natural language processing, but one of the ways we're seeing natural language processing is through video content, things that are already created. So here's an example where the CEO of Mattel, about 9 months before Toys R Us filed for bankruptcy, Mattel's CEO had said how important Toys R Us was to them reaching their customers. Now, no one really remembered that she had said this, But when I went to, when Toys R Us filed for bankruptcy, I just went into our system. I typed in Toys R Us meaning. Like, what is the meaning of Toys R Us? Well, this is what came back, that Toys R Us is a really important customer of ours. And she went on for about a minute talking about how important Toys R Us was. So that's an insight that I'm able to maybe make a decision. Does that mean I'm going to sell my Mattel stock or something like that, right? Like, and so this is something that the AI, by using natural language processing, helped bring forth some information that most humans would have forgotten that she actually had said 9 months before. We can also use AI for analytics purposes and to kind of see and learn, and we can actually see how we can make content better. And this is augmenting creatives, right, to show them where people are engaging and what they're engaged, kind of content there are. But we can also maybe automatically create that, where the AI system in the future could create content on its own. And we're seeing companies that are doing that now. But a lot of the work is around prediction and forecasting. And this is why a lot of people say that AI is really just statistics. Now, I agree with them in some points, but I make a differentiator that we'll talk about. This is one I used to love, and I wish it was still around so that you could experience it for yourself. But the fourth down bot from the New York Times would tweet, when a fourth down happens, should you punt, go for it, or kick the field goal? Now, it's looking at all the statistics, all the players, who's on the field, what's the distance, what's happened in the past, who's the kicker. All of that information is being cataloged and indexed, and then it immediately makes a decision of should they punt, go for it, or kick the field goal. But the difference between just being statistics and being an AI system is that once someone, let's just say it was a 41-yard field goal, and it was kicked and missed, then the system can look at it and see, why did I make that mistake? And I said you should kick the field goal, but I missed it. What happened? Well, maybe it discovers that wind was a factor, because it looks back at all the other misses and sees that wind in this stadium was a factor. So now it adds to itself into its algorithm to understand wind, right? And this idea of self-teaching and self-learning is what we're talking about when we're talking about an AI system. It's better today than when it was originally programmed. And essentially, most of these bots are just computer programs running on machines, and sometimes we put nice visual experiences with them. So let me show you another prediction. We had this goal of, if we had $10,000 in 3 months, could we predict an admissions committee? Okay. So the admissions committee is deciding who's getting into the MBA program. Okay. They look at lots of different factors, test scores, they interview people, they have essays, they have letters of recommendation, they have all these things. But all we looked at were the numbers. We didn't look at any of the unstructured data like essays, for example. And in 3 months, we had it to 83% accuracy. We ultimately got it over 90%, where we could determine if people were going to be admitted, denied, or waitlisted. So what do you think about that? Would you want to know that you're getting admitted to an MBA program was determined by an algorithm? What do you think?
What data was the algorithm using?
All of the application data that had been submitted by all of the previously selected and denied students, and then apply it to each individual student based on what they submitted in their application. So it was all publicly available, not publicly available, but like the person was choosing to provide that data, which included GMAT scores and GPA and all that stuff.
So you're asking us if we would want, our admission decision determined by this process?
Yeah. What do you think?
So I'm trying to understand, like, if it was, I feel like for me, I knew that like maybe a human had give it a once over like before the admission came out, because I feel like there's still a lot more computers need to learn, and I guess that's like why I need the funding to like keep it going or whatever. But I want, like, deep down, like the part of me that's like removing myself from like humanitarian or like human-centered stuff. I don't see why it's wrong, because it's like looking for certain things, but at the end of the day, a robot as of right now like doesn't have emotion, and I think that could be important if you have to submit an essay for this type of stuff, because I think that's
Okay. You do submit an essay, yes.
Okay.
But we didn't even look at it in this particular case, but we could determine what the humans would spend hours reading those essays and scoring them would have determined. Right. So Dylan, you were going to say something?
Yeah, I would not feel comfortable with this at all because humans are more than just test scores and numbers. There's a person and a personality, and just because you have certain numbers that seem to be accepted doesn't mean you're going to be successful in the real world. So I would not be comfortable.
So what about that person who has like faced adversity and they're going to be that great student that we want to give them a chance, right? This system in theory ignores that. Well, here's the thing. This system does exactly what the human committee does. So let's just assume we got it to 99.9% accuracy. So out of 1,000 students that get there, we get 999 right of exactly what the human committee determined. Now that human committee was looking at those factors. It was looking at lots of different additional factors that we would put in a human context. Okay, but we were still able to determine that based on an algorithm. Does that change your mind?
That doesn't change my mind, because there's still going to be someone who hasn't been seen yet. That's that one exception that I don't know.
Okay. What are some of the problems with the system as I've presented it?
I guess I would say like what you said about essays not being part of it, and like that one person who faced adversity, like that's not something you can put into an algorithm. So it just it takes out all like the personal elements of people and just looks at the numbers. And I feel like that's what's wrong with it.
Okay. But what about the other side of this, where the humans have their own bias? The humans gravitate to whatever their biases are. Okay. What about that side of the fact? That's not fair.
I have a question about it. If it's going off of data that's been used in the past to admit people, wouldn't it still have that human bias?
Very good, Liz. Very good. We have created a machine that has systemized and amplified any human bias already in the system. So all we've done is build a system that doesn't say if you're going to be a good student. It doesn't say if you're going to be a good business leader. It says, would you have been selected by a previous committee? Okay, because we're using old data. So the question is like, was it a good thing or not, right? I'm going to let you rest assured, this is not being used right now. Okay, this is not part of a system. But you could see how it could easily be used to admit those who are on the very top, admit those who are in the lower third, admit those in the upper third, deny those in the lower third. And then maybe a human committee determines the other third and looks at some of those human factors, right? So that you feel a little bit better on, right? Like it's kind of, those who actually, had a chance. But this is something that when we build these systems, we're training it, and we have to know what we're training it on and are there issues. This week, you're going to read about Amazon and their recruiting engine that was supposed to get more women into engineering roles. And you're going to read about all of the issues and things they faced. And it is a fascinating article that I want you to truly digest and understand what happened and then why they either chose to keep the program or abandon it. Another thing that's happening, especially in business and in the recruiting and HR, is algorithmic personality tests based on data that is publicly available. So this sentence was natural language processing generated from machine learning based on a bunch of previous candidates with similar interest in things that I have. Stephen is a skilled communicator with the ability to distill big ideas down into actions, but probably has a tendency to take on too much responsibility at one time. When I put this into this, when the system was generated, I was sitting on the couch with my wife. I showed it to her and she said, you need to frame it and put it on the wall because that is you. And she's absolutely right. This is my problem. This is my issue, but this is who I am. And an algorithm was able to determine that very quickly. Now, if I'm trying to choose an executive assistant or someone to work on a team with me, I know that I need someone who is really good at details. So I could run similar algorithms to help me find the people who might supplement me in a good way. So saying that, if you knew that was how I was choosing innovation fellows and people who worked in the lab, was trying to build a team around creating a nice balance of personality tests that was determined by an algorithm, what would you think? Just good or bad?
It could be good because like it's probably like honest in a way, but like maybe a little too brutally honest in a way. So it's like not exactly what you want to be showing.
Yeah. Have you ever been in an interview and had someone say, I'm not detail oriented? Right. Like
No.
they always say they are. I'm not. I'll go ahead and admit it. But I'm one of the very few who can admit that just because I've had so much problems with it. But in an interview, I don't know that I would admit it. But this algorithm is going to help me determine that about people. Right.
Like if I'm a fast learner.
Yeah. Isn't everybody a fast learner? You know? So this can be helpful. Now, do you think there are companies using this today?
I think yes, or something to the same extent.
Yeah. Most of your big technology companies and your big consulting firms, they are all using this in their recruiting process. And it's probably not transparent. They're probably just analyzing the data, and it helps them organize and sort through the hundreds of resumes that they're getting. But ultimately, like these types of things are being used throughout, and you're going to see more of that. So I think this is an interesting use of AI. And I think as long as it is AI that is augmenting the decision-making process, I think it's helpful. If it becomes the number one decision maker, then we have a problem, right? Like I'm not going to start hiring and firing people based on what the algorithm says, but it might influence me as I try to make that decision. Let's skip some stuff quickly. I want us to talk a little bit about computer vision, which is a big part of gathering insights for AI. So computer vision in itself may or may not be considered AI depending on how you define it, but it is very important it's another sensor for us to see what is out there, and we use machine learning to actually extract information and data. So as what you're seeing on the screen, we can understand that these are people, and we can detect that by machine learning through computer vision. So we're using a camera to detect that that's a person. This is the same way that facial recognition technology might work, or in our case, we're doing the mask detection. So we're using a model that was created and trained on videos and pictures of people wearing masks and not wearing a mask. And so it was trained by humans to detect masks, and it does a really good job. And so computer vision is a way that we extract information from the visual world. But as we've talked about all of these different kind of forms of AI, it is important to note that algorithms quickly become policy in execution. So an algorithm becomes policy by a developer wrote some code, they tested it, it worked, and all of a sudden it gets deployed to hundreds or thousands of pieces of equipment. And that could be good, and it can be very helpful, but it could also introduce any biases that developer had or the model it was tested with. So for example, if we look at the mask detection model, what if our model, which this is actually a really good example, the model was trained on people who were Asian descent because they were dealing with masks and the swine flu years before us. So we were able to take their models and use it, but it was all people of Asian descent. So what we were able to do is then supplement and retrain or add additional training things to make that better. But ultimately, if we would have just accepted that as is, we might have had a problem where we were misinterpreting the visual data that was coming. Right. So we want to ask really good questions and understand how it was made, who made it, why they made it. So it's kind of like interviewing the data. You're also interviewing the reason the algorithms were made. You're interviewing and understanding what it is, because whatever gets made is amplified by the fact that it is learning and growing over time. on the self-driving car, what if we made a self-driving car to mimic how I drive? I speed. I would not like to admit it, but I probably look at my phone at times. And if we use the human factor to do this, we would have a problem. But if we use computers to do it the way people should be driving, then we're much more likely to have a safe system. But we also need to put both in perspective, because each way could have error. And so it's not a one is better than the other. It's we have to figure out which part of the algorithm is better. For example, a human can determine if that person standing on the sidewalk is about to step out or not better than a computer can. Because in computer vision, they can measure the rate and speed of which that person's coming to the curb, but they don't know if they're going to step out or not, because a lot of people actually like walk pretty quickly and then stop as soon as they get to the crosswalk. But humans have gotten really good at determining that for ways we just don't quite comprehend. So we can train it with human experience, and we can train it with mathematical and understanding and other types of learning. So we want to make this balance. And so that's what I want to say is it's not that structured or unstructured is better. It's not that supervised or unsupervised is better. Is that we have to answer the question for each particular use case. And then under the use case, as we're doing different parts of the algorithm, that we truly understand what are the biases, what are the main things, and what are the things we need to ask as we're building them. So it may think that I've talked pretty negatively about AI. I'm actually very excited about AI. I do a lot of work in AI, but I also think it's important that we have and consider all of these ethical considerations. So this week, as you're looking on Sakai, you're going to have a couple of examples, one of which is Amazon and their recommendation engine for recruiting. The other is a China example where they have a subset of people that they're giving essentially a social score to that could have impacts on their ability to transact and do things in the future. And so I want you to read both of those articles, and then we'll talk about kind of some of the ethics behind those things. I'm also going to give you a video about the trolley problem. If you've been in any computer science classes, you may have seen this. This is a modified version of the trolley problem from the perspective of a car, of an autonomous car. So if you think about a self-driving car, we have 5 people in this car. You have 5 people on the street. The brakes have failed. What are you going to do? You got to hit one or the other. You got to either kill the people in the car or kill the people in the crosswalk. What do you do? Right. And so I'm gonna let you watch that video and think through those things, because it's not an easy answer. Right. And these are things that developers are having to work and struggle through. And there's a lot of political and business implications for every decision that is made. So we've discussed a lot of things very quickly. What I want you to do, this was supposed to be an overview. I want you to go watch the several videos that I'm going to put on Sakai and read these articles and come prepared to discuss a lot of the ethical pieces next week. Any questions?